Good morning, students. Last time, we completed chemical thermodynamics. After completing that chemical thermodynamics, we want to start another chapter from chemistry, standard 12, that is Ionic Equilibrium. You know that in 11th standard, we studied chemical equilibrium. First of all, what is called chemical equilibrium? In 11th standard already we completed the concept of chemical equilibrium, and this concept of chemical equilibrium is useful to study ionic equilibrium. So you know that in a chemical reaction A plus B react to give C plus D, and C plus D again react to give A plus B. You know the reaction between A plus B to give C plus D, that is called forward reaction, and the reaction between C plus D to give A plus B, that is called reverse reaction. Whenever the rate of forward reaction and reverse reaction is same, that is called as chemical equilibrium. So what is called chemical equilibrium? Whenever the rate of forward reaction and rate of reverse reaction is same, that is called as chemical equilibrium. So the concept of chemical equilibrium is useful to study ionic equilibria. You know that the equilibrium between ions and unionized molecules, equilibrium between ions and unionized molecules is called ionic equilibrium. For example, you know that for your understanding, suppose there are 100 molecules of water, and you know that after ionization it gives H plus OH minus. So out of 100, when 50 molecules are ionized, then they form 25 H plus and 25 OH minus. Means in the beginning there are 100 molecules of water, but after ionization they are converted into H plus and OH minus. Out of 100, suppose 50 molecules are ionized, that means 25 H plus and 25 OH minus ions are formed. Means the equilibrium is established between ions and unionized molecules. That is called as ionic equilibrium. So what is called ionic equilibrium? Equilibrium between ions and unionized molecules, that is called as ionic equilibrium. Here, with the help of this ionic equilibrium, we can determine the equilibrium constant. Ionic equilibrium is useful to determine the equilibrium constant. Similarly, the concept of ionic equilibria is useful for ionization of weak acid and weak base, and also solid salts and its ions in water. Now we want to know what is called electrolyte electrolyte and non-electrolyte. What is called electrolyte and what is called non-electrolyte? Electrolyte, substance which ionize to give ions. Ionize to give ions are called electrolyte. When dissolved in water, ionize to give ions when dissolved in water. When dissolved in water are called electrolyte. What are called electrolyte? Substance which ionize to give ions when dissolved in water is called electrolyte. And in opposite to that, substance which do not ionize to give ions when dissolved in water, that are called as non-electrolyte. For example, you know that NaCl, sodium chloride solid, when dissolved in water, it gives Na plus aqueous plus Cl minus aqueous. That's why NaCl is called as electrolyte, because NaCl when dissolved in water, it ionizes to give ions. That's why NaCl is called as electrolyte. Then what is called non-electrolyte? Substance which do not ionize to give ions when dissolved in water. That means it remains in the molecular form. For example, glucose C6H12O6, when dissolved in water, it does not give any ions. That means it remains in molecular state. It does not ionize. That's why glucose is the example of non-electrolyte and NaCl is the example of electrolyte. So I think you understood what is called electrolyte. Substance which ionize to give ions when dissolved in water is called electrolyte. And substance which do not ionize to give ions when dissolved in water, that means it remains in molecular state. That is called as non-electrolyte. Here, these electrolytes are classified as strong electrolytes and weak electrolytes. These electrolytes are classified as strong electrolytes and weak electrolyte. What is called strong electrolyte? You know that the electrolyte which are ionizing completely are called strong electrolytes. For example, strong acid, strong base and salts. Strong acid, strong base and salts are the examples of strong electrolytes. For example, HCl, hydrogen chloride, it is the example of strong acid because it ionizes completely. Similarly, H2SO4, sulfuric acid, strong base like NaOH, KOH, strong salt like NaCl. These are the few examples of strong electrolyte. What is called a strong electrolyte? Strong electrolytes are those which ionizes completely, or substances ionizing completely are called as strong electrolyte. The examples of strong electrolytes are strong acid like HCl, H2SO4, strong base like NaOH, KOH, salts like sodium chloride or potassium chloride. These are the examples of strong electrolytes. In opposite to that, what are called weak electrolyte? what are called weak electrolyte. Weak electrolytes are those which ionizes to smaller extent. Ionizes to smaller extent. So, weak acid, weak base and salts are the examples of weak electrolyte. For example, weak acid like acetic acid, weak base like NH4OH, and that is salt like NH4. That is weak acid like acetic acid, weak base like NH4OH, CH3COO NH4, ammonium acetate. These are the examples of weak electrolyte. So after having idea about why these are called as weak acid, weak electrolyte, because they ionizes to small extent. Now here it is important to know that one more important point we want to know, that is strong electrolytes. For example, NaCl, sodium chloride, it is the example of strong electrolyte, NaCl, because NaCl ionizes completely to give Na plus and Cl minus, and you know that CH3COOH, acetic acid, it is the weak acid or weak electrolyte. This is the strong electrolyte. So ionization of acetic acid, CH3COOH, is written as CH3COO minus plus H plus. So remember well, ionization of strong electrolyte is denoted by single arrow, but ionization of weak electrolyte is denoted by double arrow. That is one of the important point you should remember. Ionization of strong electrolyte is denoted by single arrow, while ionization of weak electrolyte is denoted by double arrow. Now here it is important to know that degree of dissociation, next point, this chapter Ionic Equilibrium, that is degree of dissociation, degree of dissociation denoted by alpha. So next important point from this chapter is degree of dissociation, that is alpha. Here what is the definition of degree of dissociation? Degree of dissociation of an electrolyte is defined as fraction of total number of moles, fraction of total number of moles of an electrolyte, fraction of total number of moles of an electrolyte that dissociates into its ion, that dissociates into its ions, when dissociate into its ions when the equilibrium is attained, So what is called degree of dissociation? Degree of dissociation is denoted by alpha. What is called degree of dissociation? Fraction of total number of moles of an electrolyte that dissociates into its ions when the equilibrium is attained. So, degree of dissociation alpha is equal to number of moles dissociated upon number of moles dissociated upon total number of moles. So, degree of dissociation alpha is calculated by the formula number of moles dissociated upon total number of moles, and percentage dissociation is equal to is equal to 100 into alpha. So, how the percentage dissociation is calculated? Percentage dissociation is equal to alpha into 100 or 100 into alpha. You know that if C is the concentration, C is the molar concentration expressed in molarity. If C is the molar concentration of electrolyte, the equilibrium concentration of cation or anion is alpha into C mole per dm cube. So what is called degree of dissociation? Fraction of total number of moles of an electrolyte that dissociates into its ions when the equilibrium is attained. Degree of dissociation alpha is given by the formula number of moles dissociated upon total number of moles. Percentage dissociation is equal to alpha into 100. If C is the concentration, if C is the molar concentration of an electrolyte, the equilibrium concentration of cation or anion is given by alpha into C in mole per dm cube. After completing this, we want to know what are called acids and bases. Next point. Acids and bases. Next point. Acids and bases. Acids and bases. You know that we are familiar with different acids in our daily life. You know that acetic acid is present in vinegar. Acetic acid is present in vinegar. Similarly, you know that citric acid is present in lemon. And you know that tartaric acid is present in tamarind. Tartaric acid is present in tamarind. Tartaric acid is present in tamarind. Here it is important to know that magnesium hydroxide is present in antacid. MgOH twice is present in antacid. Similarly, ammonia is present in different household cleaning products. So, in the beginning, when we are going to start what are called acids and bases, We are familiar with acetic acid as it is present in vinegar, citric acid is present in lemon, tartaric acid is present in tamarind, magnesium hydroxide present in or is used as antacid, and ammonia is present in various household cleaning products. We know all these substances. Here we want to study the definition of acid and bases and what are the correct definition of acid and base given by different scientists. First of all, Arrhenius theory, scientist Arrhenius given the definition of acid and base. After that, Bronsted-Lowry given another definition of acid and base. After that, Lewis given modified definition of acid and base. First of all, according to scientist Arrhenius, what is called acid? Substance which contains hydrogen. Acid. Substance which contain hydrogen. Substance which contain hydrogen. And gives H plus ions in aqueous solution. And gives H plus ions in aqueous solution. That is called as acid by scientist Arrhenius. What is called acid by scientist Arrhenius? Substance which contain hydrogen and gives H plus ions in aqueous solution. That is called as acid. Here you know that HCl, aqueous, in water it gives H plus aqueous plus Cl minus aqueous. So HCl is called as acid by scientist Arrhenius. Why? Because HCl is a substance which contain hydrogen, and gives H plus ions in aqueous solution. Means when HCl is dissolved in water, it gives H plus ions. That's why it is called as acid. Then what is called base? What is called base by scientist Arrhenius? Substance which contain OH group and produces OH minus ions or gives OH minus ions in aqueous solution, that are called as base. What is called base by Arrhenius? Substance which contain OH group and gives OH minus ions in aqueous solution, that is called as base. So we can write NaOH aqueous in water, it gives Na plus aqueous plus OH minus aqueous. So substance which contain OH group and gives OH minus ions in aqueous solution, means in water, that is called as base. I think it is clear that what is called acid and what is called base by scientist Arrhenius. Now there are some drawbacks or some limitations, because you know that applicable only to aqueous solution. Aqueous solution. And here it is important to know that it does not give the acidic and basic characters of some substances. For example, you know that NH3 ammonia is a base, still it do not contain OH. So this was not explained by scientist Arrhenius. That's why these are called as drawbacks. Similarly, Na2CO3, sodium bicarbonate, Na2CO3, that is sodium carbonate. You know, substance which contain hydrogen and gives H plus ions is called acid. Substance which contain OH group and gives OH minus ions in aqueous solution is called as base. But here, the drawbacks of Arrhenius theory is that the basicity of ammonia and sodium carbonate cannot explained by scientist Arrhenius. First important drawback is that it is only useful for aqueous solution and it does not explain the basicity of substances like NH3 and sodium carbonate, because NH3 do not contain OH, still it is base. It do not contain OH, still it is base. This was not explained by scientist Arrhenius. Okay, we will see next definition in next lecture. Thank you.